All right, let's take a look at another problem. We've got number 39 here, part C, where we're evaluating the limit as x approaches pi of pi minus x over the sine of x. Now in this problem, we're going to approach it a little more formally because they want us to use a let statement. And a let statement defines a variable that's not present in the problem. So this let statement is t equals pi minus x. Okay, so that means that in our original problem, we're going to convert everything that has an x in it over to t. And that includes the constraint on the limit. As x approaches pi, we have to figure out where t is going. Okay, so over here in my let statement, as x approaches pi, where does t go? Okay, and that's the question here. Okay, so basically what we're doing is we're taking a limit in our let statement. We're saying the limit as x approaches pi of t. Well, by our let statement, t equals pi minus x. So this limit is x approaches pi of pi minus x. And right there, we're dealing with a polynomial in itself. We can use direct substitution. So we get 0. So as x approaches pi, t goes to 0. So this question mark here is 0. So as x approaches pi, t approaches 0. Okay, the other thing we're going to have to worry about is we're going to need to replace x over here into terms of t. Well, we've got t equals pi minus x. Well, that would mean then that x equals pi minus t. Okay, so now it looks like we've got everything in terms of t and able to plug into our problem. So we've got our limit now as t goes to 0. That's from our let statement. Instead of pi minus x, we have t. And again, that's according to our let statement. Now we've got the sine of x, but instead of the sine of x, we have the sine of pi minus t. Okay, so now we've got a limit, an equation here where we're evaluating the limit of as t goes to 0. We're all in terms of t. So everything looks good here. However, we do have an angle difference in the denominator of sine, and this one happens to be a supplement theorem for sine because we're dealing with the sine of the supplement angle. And if you wanted to verify that the sine of the supplement is the same as the sine of the angle, we could draw a unit circle for that. We could also use the angle difference for sine, which is sine cosine, cosine sine, same sign for the sine. So I've got sine pi cosine t minus cosine pi sine t. We know the sine of pi is 0 times cosine t minus cosine pi we know is -1 times sine t. So we end up with 0 minus sine t, or just sine t. So for this problem, that means that we've got our limit as t goes to 0 of t divided by sine t. And again, that should be familiar. We've got one of the basic theorems for trigonometry and limits around 0. We've got the limit as t goes to 0 of t over the sine of t, and we know that that equals 1. We got a real number value. So in this one, we had the limit as x approaches pi of pi minus x over the sine of x. We were given a let statement to work with that t equals pi minus x. From there, I did all of this manipulation to put everything in terms of t, even the constraint on the limit, because I have to have x going to pi. That means I have to have t going to 0 in my new problem once I swap everything out according to the let statement. And in this case, we end up with 1. And again, this should provide a clear example why this actual limit, once we evaluate it, equals 1. Okay.